Okay. Good evening, everyone. So we're going to start already our workshop for today. Before we start, we'll
Okay.
just
Good
going to have a
evening,
quick
everyone.
introduction
So we're
about
going
what
to
we do at AI Pilipinas and what are the programs that we are offering to the community. So, what is AI Pilipinas? So, for those who are new in the community, so we're a group of Filipinos who are willing to upscale tech capabilities regarding machine learning and artificial intelligence. So, we build this community to have that group in which we can actually learn from one another, learn best practices, and enable us to build cutting edge solutions that can either be used for research purposes or to develop solutions that can actually be used in the industry. So this group enabled us to learn from one another and actually promotes collaboration and exchanges of knowledge and best practices. So right now we have at around I think 1,800 plus members via the Facebook group. We also like present and meet up. So if you're not part of the meetup .com group yet, so please make sure that you visit the website. We have at around 800 plus members there, and we also like announce all of those and all of our events via those groups. So we have been organizing events for the past years. So we started building the community way back in 2017, in which we were able like to teach TensorFlow in different parts of the Philippines. So we've been in Davao, we've been present in different groups also, and different offices here in the metro. So in 2018, we started to work with the TensorFlow Dev Summit here in Manila, in which we asked participants to share about their projects and also talk about some of the researches that they have been doing, leveraging the capabilities of TensorFlow. And we have expanded all of this effort, partnering with different organizations such as Microsoft, Globe Labs, and Google, in which they're actually hosting all of these events and meetups for last year. We have also like hosted the first ever machine learning hackfest in 2019 at Google, in which the primary goal of this activity is to enable developers to work with social good projects. So for this year, we're actually launching TensorFlow Project Showcase. So the primary goal of this initiative is to actually share whatever TensorFlow projects that you have, that you guys have been doing, or if you don't have any TensorFlow projects yet, this is a time for you to showcase your capabilities, leveraging the power of artificial intelligence and machine learning using TensorFlow as the platform for this for the projects that you will be developing. So if you would want to know more about the TensorFlow Project Showcase, go visit the website aipilipinas.org. But for those who are not yet familiar and haven't read yet, what is the TensorFlow Project Showcase? So the mechanics of this activity is participants can either be individuals or teams. So teams should consist of not more than 3 members. So you can form teams to create applications on TensorFlow, or you can be an individual. And if you have many applications that you have developed previously, so you can submit all of those as long as they meet the eligibility criteria and requirements. So participants are allowed to submit multiple entries and make sure also that they meet this criteria and requirements that's needed. So participants who will be joining the activity must completely fill out and submit the project application review form. And the application deadline is on November 27. So that's already next month. So applications should be your original work and haven't been submitted yet to any contest. You can submit past projects that you have been doing. It could be a research project that you have been working in class, or any pet projects or creative projects that you have been working on the side. So you can submit all of those, or you can completely build a new one. That's why you have this workshop to help you guys understand how TensorFlow can actually be a good resource for you to build these projects. So applications submitted to the contest should be publicly accessible. So you should be able to use that using a web or a mobile, and it must be an open source project. So you should make sure that you can that your code should be uploaded on any publicly accessible repository such as GitHub. So the winner selected will be based on a panel judging and public vote. So how do we judge the submitted applications? So first, we're going to check on the functionality. Does the app work? Did the team achieve the goal they defined? And was the solution innovative? So for technology aspect, that's 40%. How technically impressive was the application? Was the app difficult to build? Difficult? Did it use particularly clever techniques in building that solution? And did the technology involved make us like go wow? And on 20%, that's where the design factor would be considered. So did the participants put thought in the user experience, and how well did you design the interface? And for number four, we'll be asking the public users to actually look into these applications and have them vote as what they think they feel is a good TensorFlow application for them. So what will be the prices for this activity? So winners will receive support to take the TensorFlow developer certificate. So that's relatively worth 100 US dollars. So we're going to provide the money for you to take that certification. And all accepted applications. So even if you don't win, and you just submitted your application to the showcase itself. So all accepted applications will also get a chance to win prizes. So we're going to raffle amongst all of the accepted participants, and they had a chance to win a Google Home Mini and Chromecast through our raffle. So even if you didn't win and wasn't able to get the TensorFlow Developer Certificate support, you still have a chance to win some exciting prizes through the raffle. So contest schedule, as mentioned, we will be having a series of workshop from October and November. So November 27 is a deadline of application. December 4 is scheduled to have the panel judging and public voting, and we will be announcing the winner on December 11. Okay. So what are the trainings and workshop that we prepared for you guys? So for today, we have Rodolfo with us today to talk about how to build your first neural network on TensorFlow. This is relatively important for those who are going to start their application TensorFlow. And then next week, he will also be joining us same time, and he will be discussing image classification in TensorFlow. So if you're working with images, if your data are images, so this is the right activity and workshop for you. On October 31, Yogesh will be discussing about RNN and sequences. On November 7, we're going to be utilizing TensorFlow JS. So if you are keen on building web applications, TensorFlow.js would definitely be a fit for you. So it's on November 7. And on November 14, we'll be discussing TensorFlow Lite. So if you are keen on building applications on mobile, so TensorFlow Lite is a good topic for you guys, and Henry would be helping us with that. And if you are keen on analyzing text data, natural language processing, so we have text classification in TensorFlow by Tierno on November 14. So we have relatively a jam-packed week-by-week workshops set up for you guys so that you can speed up your learning on TensorFlow and help you build the applications for the activity. So for today, we will be covering our first topic. So I'll be giving a quick introduction to our speaker today.
Okay. Okay. Okay, so welcome everyone. I think that we are ready for this very first workshop on how to get introduced on some ways to develop our intelligent solutions using TensorFlow. So it is my pleasure to be here with you from Mexico. And when I say it's my pleasure, I really mean it because right now it's like 6 in the morning right here in Mexico. So welcome everyone. So okay, let me just quickly introduce myself. Well, I'm Rodolfo Ferro. I'm from Mexico. I'm part of the Google Developer Experts community around the world. So I'm an expert in machine learning. And I also work as part of an education program for Microsoft here in Mexico. So I have been working for some years developing some machine learning models, actually using TensorFlow. So I mostly focus on the applied part of machine learning. So I try to build like very tangible solutions. So that's it. There you can find my information. So if you can want to get in touch or you want to sit, you can drop me an email if you have any questions. Okay. So let's check about the contents for this session. First of all, I want to share with you a quick motivation that will give us a brief context about how we normally like program or yes, write our programs, and then what happens with the machine learning systems when we try to program machine learning solutions, right? So then I will try to explain what will happen with this logic about machine learning paradigm. So I will try to share with you um, this idea. So then after this part, we will try to explain the main idea of how neural networks actually work. So I will try to explain the main idea of how an artificial neuron actually performs the the processing that it has to do, like to uh, to keep the information flowing so it can create like so it can classify or do whatever we want to do with this network. And after that we will directly jump into the TensorFlow code. So okay, let's start. First, let's try to motivate this session, this workshop. So let's try to think about this specific case. So let's consider this person. Let's say, let's call her Sarah. So we have Sarah, and we try to recognize the activity that she's performing, right? So the idea is that she's like linearly moving, and we have some information about her activity. Maybe we have her speed, so we can think in our traditional way to program systems. We can think about conditioning the information that we have in order to try to recognize what she's doing. So we can think on this example that, so we can think that if her speed is actually lower than 4 units, whatever units of measurement we are using, we can think that Sarah is it's just walking. So extending this idea, we could also think that if the speed is over 4, we can think that Sarah, I always change her name. We can think that Sarah may not be walking, but she may be running. If we continue extending this idea, we could add more conditions about the information that we have about this case. So we can now condition the speed to know if Sarah is running or she's riding a bicycle. But the idea is that with our usual way to code, to program, like to create solutions with information that we have, we usually try to create rules to understand what, yes, to understand what is happening. So in this case, if we try to recognize the activity, maybe we can create rules to work with the speed or any information that we have for a problem. But the idea of continue extending these examples is that maybe for more complex information, it would be very difficult for us as humans, like to create the rules, like to have nice results, right? So the idea of this is that we can solve these kind of situations using machine learning. And the thing is that in our traditional way of programming, what is happening is that we usually have data, and we give a system, we give the rules to a system, so the system can give then can gives us back some answers. So if we think about the example, we could think about the data that we could have from this example. The data we have would be just the speed, and the rules could be like just the conditionals that we are using, like to identify or recognize the activity, right? So this is what will happen with traditional programming, and we will get direct answers depending on our rules and based on our data. But the idea on machine learning is that we change this traditional way of building solutions, in the sense that we just create a system in which we only share some answers and some data, and the system will understand what is happening from the data in order to build the corresponding rules. So in the case of trying to generalize the activities that Sarah would be performing, it will be very difficult for us maybe to try to define some rules to identify when Sarah is it's playing golf, for instance, right? So the idea is that with machine learning, this would happen. This would change the whole idea of our traditional programming, and we only need to show a lot of examples to our machine learning system, so it can understand what is happening with the data, and having like the labeled data, it will try to like adapt the rules that perform better for the data in order to give the correct answers. So trying to land this, in our case, what we will be building is a neural network for which we will be feeding the network with data and with answers, and the network is going to build the rules. So thinking about this whole concept with the example of Sarah, we could try to think about representation of the information that we have. Maybe try to transform the data representation that we have. In this case, maybe the speed. Maybe we could have any other information, such as the heart rate, the when you measure the your heartbeats. So maybe we could have any other complex data, and what would happen is that our machine learning system would try to identify some important features, and with these features at a high level, our system would create the corresponding rules in order to identify the corresponding activity. So this is our core idea of what we will be using, and with this core idea, we will be like developing our neural network models. So let me share with you now what would be one of the paradigms that will happen with machine learning, in the sense that we could see how a machine learning uh, I mean I'm trying to let me try to think about this. Um, I can share with you this paradigm in which we can think about it as a process that will happen when we try to train a machine learning system. So the idea of this and what will happen is that training a machine learning model by feeding the model with data and answers, uh, this process is an optimizational process in the sense that that at a very specific point, at a starting point, our model will try to make a guess of the data. So the idea is that if I have a model at the beginning, it will just make a random guess, and what will happen next is that we will try to measure the accuracy. Since we have example data, as we have data that we are using to feed the network, and we have like the answers, we can measure how our system is performing compared with the actual answers that we are expecting. So we can compute like an error. So we can have an estimate of an error, and with this, we can measure the accuracy so far of the system. Then what will happen next would be that we need to optimize our guess. So the idea is that if we can compute an error based on our random guess in our initial state, and having the answers, since we can measure this error, we can use this error to try to fix our guess on our machine learning system. So this is the paradigm that we will be using, like to optimize our neural network. So this is a process that needs to be repeated. So in an iterative process, this will bring us a nice approach of a trained model that will give us reasonable, good answers. So this is our paradigm that we'll be using, and this is like the core idea of what we will be doing, like to train our model. So an interesting thing that will happen with this idea is that we once we work with this paradigm and we feed our machine learning model with the data, we optimize our guesses, the machine learning will understand the rules that redundantly rule the information, the features that the data has. And what will happen is that at the end we will have a trained model for which, if we feed our trained model with new data, it will be able to give us back some inferences. So it will be able to to give us answers to data that the model has not seen yet. So thinking about the example for recognizing the activity that Sarah is performing, at the end of after we train a model, we'll have a model for which, if Sarah is performing any activity, we can feed the information from this activity to the model, and this model will be able to identify the activity that Sarah is performing. So this is what will happen at a high level. I mean, many technical, very technical, deep technical stuff will be happening behind all this, but at a high level, this is what will be happening. Uh, I will be explaining some other concepts about what happens with deep learning specifically, since our approach will be uh, on building our model. Our approach will be to create a neural network, and we will try to solve a very simple problem, and we will learn how to create a model like this one using TensorFlow. And we will realize that it's actually a very simple way to create a model. So far, thinking about this high level, what will happen is that as the model learns from the data, uh, what will happen is that the model will also learn some relations that are happening on the data and that may not be like quite easy to see for us as humans. Maybe we could have like very complex relations between the data. And what will happen when we work on all this process of optimizing our model is that our model it's actually going to learn about some relations from the data. So these images look like very artistic images. Actually, fun fact, I generated those images with a neural network. And I just built those images to have like a visual representation of how complex data could be like modeled using a neural network. So yes, it's just like a bit of an artistic image. But let's try to understand what will happen with neural networks. Since we care about how at a very basic level, our neural networks are going to work. So first of all, I think that it's important to mention that as it happens with other areas of science, a scientist usually observes natural phenomenons or whatever, and they come out from this observation. They come out with an hypothesis, and they try to experiment and validate this hypothesis. And the idea is that from observing a natural phenomenon, they try to describe what is happening with that phenomenon. And many natural phenomenons have served as inspiration for many things in science, and specifically in computer science. This has led to many scientists to create many algorithms that are inspired in what happens in nature. And one of the biggest bio inspirations from nature observation is the neural networks concept, because the core concept, or at least our neural networks concept, comes from the actual way of working of neurons inside our brain, in the sense that neurons receive information, they process the information, and using a synaptic connection, the information keeps flowing to the next neuron. And this is the whole process of how neurons transfer information. So with this idea, computer scientists created an abstraction of how these natural neurons work. And this, let me try to, oh, here's my mouse. Okay, so this image on the left represents this abstraction of how a natural neuron works, like thinking about a neuron of our brain. And the idea is that this abstraction represents a neuron, and the blue circle will represent like the nucleus of the cell, since neuron is a cell. And this will represent the nucleus in the sense that it's the part of the neuron that will process the information. So the idea is that a neuron has dendrites. So those parts are the parts that receive the information, maybe from another neuron. And this will represent, in our abstraction, the dendrites are represented with this set of gray circles. And the idea is that the information that feeds an artificial neuron could be any kind of information. Maybe if you have a sensor that is sensing maybe humidity and temperature, we can think of those measurements as the information that could be served to this artificial neuron in this case, right? So the idea is that an artificial neuron will just perform some operations with this input information. And in this case, with the abstraction that our scientists along history defined for this abstraction of neuron, was that if we have information that it's just getting right into the neuron, we assign a value that represents, like, we can think about this value as a value that measures the importance of that data input. And what will happen is that the nucleus of this artificial neuron will just process the input information based on the weight. That's why this uh, these these features are represented with the letter W. It's because we call these information weights. And the idea is that our nucleus of the neuron will just multiply directly the input information with its weight, and after this, it will just perform a sum. We call this a dot product, and could be represented with this expression. So the idea is that if we receive input information, thinking on this example of measuring humidity and temperature, we could have just a vector of two input measurements, one for humidity and one for temperature. And the idea would be that a neuron would need the weight for associated to the input data, and at the end, it would just sum the product of the input data for its corresponding weight. Also, another representation of this operation would be a vector representation, in the sense that if we represent the dot product, we could think about this representation using vectors, and that's it. But the idea is that if we have like this representation and we understand how one artificial neuron works and how it processes the input information to generate an output that could be sent to another neuron, we could extend this this concept of artificial neuron to build a network consisting of several units of several artificial neurons. And we only need to extend the representation that we already have, since we could think about input data, uh, the data that we have from any measurement or whatever. Uh, and since the input data has an associated weight, we could think that we could have, and we can extend this notion and have several neurons, and then just extend the representation that we have, in the sense that if we could represent a set of weights with a single vector, we could extend this notion and use matrices to represent all the weighted connections between the information that is flowing inside a neural network. And it might be a bit difficult at the beginning, but the idea is that if we understand this part, we can, if we get how these things are connected and the representation, we could, at a high level, understand why neural networks learn complex relations between data, because the interconnectivity and how the information flows between the neurons. And so far, I don't think that we need to get very deep into this theory, because the idea of this workshop is to create our first neural network using a high-level API that TensorFlow has. And I just wanted to explain this part because I just consider important to understand what operations will be performed in the background. But anyway, just to be a bit formal about this part, the structure that okay, I will talk about the structure of neural networks in a while. Actually, I want to share with you the a notebook that we'll be using so we can write code online. So I will be showing some code, and you can like modify the code and so on. I will talk about the structure of neural networks in a while, but I first want to share with you this URL so you can open directly the code that I will be using. I think that I will share with you this URL, Ralph. So maybe if you can share it through Facebook or any other place. So, okay, if you go to this link, you will find a GitHub guest that will have actually a Jupyter notebook. So if you are familiar with Python and this scientific environment, you know that Jupyter notebook, it's like an interface to work with Python code. But anyway, you don't have to worry about installing anything because we will be using tools provided by Google that will allow us to work directly on the cloud and will actually let us use GPUs to train our model. So this is one of the important things about this tool. So if you go to the URL, you will be redirected to this link that contains this GitHub gist. And what we need to do is just click this button that will open our notebook in this Google Colab environment. And in this environment, we'll be working and coding our very first neural network using TensorFlow. So first of all, I want to give you a quick introduction to this environment because I think that this environment is the environment that will be used for the next workshops. So it's important to understand how it works. So a quick intro to this environment is that this is an interactive notebook. So it's composed mainly by cells. So we have cells that could be of two types. One type of cells, clearly, one type of cell is a text cell. So we can write description, we can document our process and whatever we're working on this notebook. So these are the cells that will work for that. So if we want to modify a cell, we can just click twice the cell if it's a cell that is already created, and you can modify the cell. If you are familiar with Markdown syntax, Markdown is the markup language that is used like to format the cells. But if you are not familiar with Markdown, but you know how to format messages in WhatsApp or Telegram, then you almost know how to write and format text using Markdown. So if you want to follow if you're planning to follow this code, and if you want to write your personal notes, like with more description about what will be happening so far, you can directly create a new cell, and you can start just writing your notes. So that's it. So yeah, this is why I really like this environment, because it's a very complete environment that it's very like dynamic. So it's very useful for workshops actually. And that's it so far. The other kind of cell, because I mentioned that we have two kind of cells in Google Colab, the other kind of cell are the code cells. So we will have cells in which we will be able to write Python code. And the idea of being an interactive notebook is that we could run specific blocks of code by running cells. So the idea is that we will be splitting our whole Python code into different blocks, and we will be running those blocks inside these cells. And that's all that we need to understand so far. What will happen with this Google Colab is that this Google Colab, this notebook, connects directly to an instance of a Google server that has CPUs, GPUs, and TPUs. So this will be very useful. Sorry, this part, if you go to change runtime type, you will see that this has CPUs, GPUs, or TPUs. So this will be very useful to train our models, because you may know that when we work with very deep models, they actually consume a lot of computational resources. So it's a recommendation to use GPUs for this part. So the idea is that this notebook will help us, so we don't have to worry about this part. So it will be training on the cloud, and everything will be happening on the cloud. So thank you, Google, for this tool. First of all, my recommendation before starting to explain the code and the contents of the notebook is to create or save a copy on your Google Drive. Why? Because since we open a notebook directly from GitHub, here we can see the GitHub logo. This means that I loaded this notebook directly from GitHub. What will happen when we load a notebook directly from GitHub is that we won't be able to save changes. So if you want to keep playing with the model and things like that, I highly recommend you to, from the beginning, to save a copy in your Google Drive, so you can save your changes. So that's my first recommendation. In my case, I won't save a copy in Drive because I already have one copy in my drive, and actually I don't want to modify it. But anyway, I will work directly with the version that it's loaded from GitHub. So first of all, I will just need to connect my notebook. And this is my quick intro to Google Colab. Once that my notebook is connected, it will be able to run any Python code that is inside a code cell. So, okay, the contents of this notebook. First of all, a quick intro to Google Colab, which has happened already. I will talk a bit about TensorFlow for people that may not be quite familiar with TensorFlow. Then I will take advantage of TensorFlow in the way that it already has some data sets inside the package. So I will show you how you can import some data. And after that, we will be working on creating our very first neural network. So after this part, we will just like keep working on the model. So that's the idea of this of what we will be working on. Okay, the quick intro to Google Colab has happened. So I will talk a bit about TensorFlow. TensorFlow, as you may have heard, it's a very popular package to build AI models. So it is a package developed by Google, and it has been a very important package for developing AI models, in the way that it has grown a lot. At the beginning, it was like just a package that that grabbed some functionality to build neural networks in a high level. So we wouldn't like care too much about programming the optimization part of the modeling. I mean, the functions that compute like the optimization part, when you try to minimize the error that is given by our random guess. So as TensorFlow continue growing, it continue focusing on the applied part, since it's one of the topics that it's important to Google, like to build technologies that could be used to build applied solutions to real problems. So TensorFlow kept growing, and they created TensorFlow JS. So at some point of this set of workshops, you will have a specific workshop in which you will be working with TensorFlow JS. Uh, TensorFlow has moved also into the serving part. So if you want to deploy artificial models, TensorFlow actually is a very, very good option. So actually for this project showcase, TensorFlow is the ideal package to be working with. And okay, TensorFlow, it's a very complete ecosystem. And for the package that we will be working on, just TensorFlow, it contains a module inside called Keras that has a high-level API that will let us create neural networks in a very, very simple way. So first of all, as you may think, if you have worked with Python before, you know that there's an issue sometimes when you have to install packages. Another cool thing about Google Colab is that Google Colab already has a lot of packages installed, so we can directly open a Colab notebook and start working with TensorFlow. And this is what we'll be doing so far. If I run this code, in my case, I will get a warning because I'm running the Colab notebook that is loaded directly from GitHub. But in your case, if you created a copy, you won't get this warning. The usual way to import TensorFlow is to import it with an alias. So the alias for TensorFlow it's TF. And here we can see that TensorFlow is already installed in Google Colab, so we can directly start working with it. TensorFlow, with its module called Keras, has already a lot of data sets. Actually, if you go to the bottom part of the notebook, you will find useful resources. So I will just try to open any of them. I will open one of these links, and these links will take you directly to the documentation. What I want to do is to show you directly from the documentation that Keras already has some data sets inside. So the idea is that TensorFlow with Keras as a high-level API has a lot of data sets that we could use, like to get started building neural networks. So we will be working with a popular data set called the Fashion MNIST data set, which is a set of images that are 28 by 28 pixels. So these are not like very big images. But the idea is that this data set has 10 different classes of clothing. So we will be able to find like shoes, like pants, like t-shirts and things like that in this data set. The way to import data sets using TensorFlow is that we will call TensorFlow, then the Keras module. Then inside the Keras module, there's another module called datasets, which will have all the datasets. So actually, if I run this in another code cell, I will be able to see, just let me change this, sorry. We will be able to see all the datasets that are contained in the Keras module. So maybe if you have worked before with other packages, maybe scikit-learn and others, some of these datasets might be familiar for you, like the Boston housing for price prediction, CFAR10, Fashion MNIST with the handwritten digits and things like that. So the idea is that Keras has also its datasets, and we will be working with the Fashion MNIST. So I will just run this out, and this will load directly the Fashion MNIST module, which has a function to load the dataset. On this cell, I am doing the following. When I call the load data method from the MNIST fashion object, what will happen is that I will load data into sets. For people that may not be familiar with some of these concepts in machine learning, what will happen, thinking about this machine learning paradigm that I shared with you, when we make a guess with the data that we use to train the neural network. So at some point, we have to clarify that to train a model, we need a specific data that is used specifically to train the model. Let me share with you an example so we can understand better this part. If I have a model, if I think of a child, this is a very example. If I think of a child that it's walking with his mom, and then the mother and the child find the dog, what will happen is the mother will tell to the child that, like, look son, that's a dog. And the kid, if the kid has never seen a dog before, he will be like, oh, okay, that's a dog. If they continue looking a dog, what will happen is that at some point the mother won't need to tell the kid how a dog looks like, and whenever they see a dog again, the kid will be able to say to his mom, like, mom, look, that's a dog. At some point, the kid learns at a high level how a dog looks like. So maybe the kid will learn the about how a dog looks like. Maybe he will pay attention to the ears, to the tail, or whatever other details that define a dog. And this will happen also with our models. So we translate this example to our machine learning models. And in this case, we are going to feed our model with a lot of examples. That's why we are loading our data set. And what will happen is that from our data set, we are going to split our data set in the images that will be seen by the model. So we can think of the dogs that the kid was looking at when his mother was like, hey son, this is a dog. And we are going to save another set of images that the model has not seen, and that the model actually is going to never see, because we're going to use those images to test the model. Because an important thing is that we care about measuring the performance of our model. So this is why it's important to save a set of images to test our model. So this will be examples that our model will never see, but that we're going to use to test our model. So that's why when we call our load data function, the load data function already splits the whole data set into these subsets: the subset for training the model and the subset for testing the model. Now, you might be thinking, how do these data look like? And for this, I have one code cell that if I run it, I can specify the index. I must mention that the training set consists of 60,000 of images of clothing, and the test images is a set consisting of 10,000 images. So we have a lot of information to train our model. But how do this data set look like? I can access directly to the training images, since it's a list. Since the training images is a list of images, I can directly access any item of this list by specifying the index, and I can plot it using matplotlib. So if I plot the image, I can see an example of how this data set looks like. If I change them, and I actually print the matrix that represents this image, I can see actually that the information has pixel values that go from 0 to 255. This is going to be an important thing to remember in a moment. So if I want to keep exploring the data sets, I can just change the index, and I can see here, for instance, that this is a sandal. Uh, Maybe let's try with another index. Here I can see that I have a dress and the matrix representation. So, okay, at least I have an idea of how the data set looks like. And in a low level, these images are loaded as matrices. And as I mentioned, the data goes from 0 to 265, because 265 is the representation of 2 to the power of 8, and it's because of the standard memory space that it's used to to represent images, right? So first of all, after creating and working with a model, it's important to mention that the representation of our data will be very important. And I have to mention this because if you are going to be working on projects because of this event, the project showcase, you have to think about the best representation of the data that you could gather to solve your very specific problems. So in our case, with the example of Sarah, if we think about an example, we could think about changing the representation of the data for her activity in the sense that I changed the speed variable for a binary representation, maybe in this case. In this case, actually, the matrix representation of the image will be the representation that I will be using, but with a slightly modification that I have to apply to this matrix. Since I have noticed that the values of the pixels go from 0 to 265, it's better for us to normalize the data that we have. So if I want to normalize the data, so my range of pixel values goes from 0 to 1, I just need to divide all the pixel values by 255, because that's the highest value, right? So I can normalize the data directly with a vectorized NumPy operation, just by dividing the complete set of training images and test images by 255. And actually, this will preserve the matrix representation, actually, because if I try to print the first image after I normalize the data, I see that actually the image representation it's kept in the structure, right? So we only transform the data and we have understand the data, and again, it will be important the representation that you will be using for your data. So far, we have prepared some data, so we can think about a model that we want to build. Thinking again about this neural network representation in terms of the operations, a neural network, just a single neuron, could be used like to linearly understand the relation between the data that we have from the input. But when we combine different layers, as I mentioned, we get like more complex representations of the data in a very high level. And that's one of the most important features of neural networks. Because if we build like neural networks, like all the hidden connections between the artificial neurons, learn this representation and understand better behaviors from the data that we're working on. So before building the model, now I will talk about the structure of neural networks. So for those that are not familiar with neural networks are usually structured in this way. We usually have three layers, mostly three different kind of layers. First kind of layers are the input layers, which consist of a layer of information with the input information that will feed our neural network. The second kind of layer is the output layer, and it's the last layer that will give us back the results of our network. And what happens with neural networks is that neural networks may have a different number of layers that are between the input and output layers. These are called hidden layers. And these layers may have different configurations. Actually, you will see in the following workshops that hidden layers, depending on the operations, on the structure, and on the architecture of how neurons are connected, will perform different results based on the operation of all this structure. But the idea is that so far we only need to understand that neural networks will have input layers, hidden layers, and output layers. You will get quite deep in more details about this kind of layers in the following workshops. Actually, for the next workshop, we are going to be working with a specific kind of layers that work perfect for images. So the idea is that we will be stacking a set of layers that will that will build like the complete architecture of our neural network, consisting of different units, processing units that will be our artificial neurons. So what will happen is that with the Keras module, that is the high-level API that TensorFlow has, this Keras module has two main ways to build a model. The Keras module, tf-keras.models, the Keras module has a models module that contains two main kind of models. The first one is the model object, which will allow us to create very complex models that maybe won't be following a specific sequential structure, let's say, of neurons, but that will perform different connections for different architectures of neurons. So this will be a bit more advanced topic, but you can check more about this on with the reference that I added at the bottom of the notebook. And the other kind of model is the sequential model, which will allow us to create a single neural network, and we will be able to keep stacking new layers of neurons. So for this, our first case, we will try to build a neural network based on our neural network concept that we have here, that in the sense that we could have input layer, any number of hidden layers, and then an output layer. So this is why we are going to be using the sequential model. So there are two ways to create a model using Keras. One way is to directly create an instance of the sequential model, and then we could specify with the add method any layer that we want to add to the model. For instance, if I want to add a layer consisting of maybe 4 neurons, I would work with a specific kind of layers from the layers module that Keras already has implemented, that is called dense. This dense layer, it's going to add a new layer with the number of neurons that I am specifying. So this, for instance, if I just add 4 neurons, this would be the analog of building a neural network similar to this one. I'm just adding one hidden layer with 4 neurons. This is one way to build our sequential model. Another way to build a model is to specify directly in the sequential model. When we instantiate the sequential a sequential model, we can directly specify with a list all the layers that we want to use for our model. So let me explain what we will be doing with this part. And after this, we will run our model and we will be experimenting with the structure of our neural network. Going back to my diagram that I have in here, our input data, for instance, in this case, consists of a set of neurons for which each one will contain a specific information, a specific data value from our data set. So the idea is that if I am working with an image for this first case, if for with a matrix, I can like to stretch all the matrix to have to go from a squared representation into a vectorial representation, into a vector representation, and I would have just a single vector containing all the stretched information of my input data. So for this, we will realize that Keras will have a lot of kinds of layers. So one kind of layer is this flattened layer. So what I am doing here is just this step. I am stretching the matrix representation of my image. So I am stretching it into a vector. And if I had a matrix that used to be 28 by 28 pixels, I will come up with a vector of 788 pixel values. So this is what this first layer will do. So we can think of this layer as the input layer, since we are since in this layer we are going to be passing the input information. And our last layer will be a layer consisting of 10 neurons. Why 10? Because we have 10 different classes, and what we are going to be doing is that if we have different classes, for instance, we have one class for pants, one class for t-shirts, one class for dress, one class for shoes, and so on. What will happen is that at the end, when we train our model, we want to associate the input data with an output value. So if I input an image of a dress, what our neural network is going to do after the process, when it makes the inference, when it tries to classify the data that it's fed to the neural network, is that our neural network, it's going to assign a probability of the occurrence of that class. So if I feed, for instance, my neural network with a dress, at the end, I would expect a result something like this, maybe 89% of probability that my input image was a dress, and maybe 2% of probability that my input image was a shirt, and so on. And the idea would be that if our network is going to inference on the probability of the associated class for an input image, we will just need to compute the maximum value of that resulting vector. So at this point, this is why we are going to be adding one last layer, the output layer, consisting of 10 neurons. The hidden layer will consist of 128 neurons. So a thing that I should mention is that, as you can see, I have specified an argument called activation. What happens, let me go back to this part, when we process information that goes inside an artificial neuron, what happens is that after the neuron processes the information in the processing nucleus, let's say, once the information is processed, the neuron needs to keep the flow of information. So the thing is that after processing, we need to kind of filter. We can think of filtering the information in the way that we apply a function to the output of the processed input. And this function that is applied to the processed input, in a way, it's a way that filters the amount of information that goes to the next neuron. So at a high level, that activation function, that's how we call this function that goes here. That activation function is what we specify and what will occur on at the end of a layer. Once the information from a previous layer is processed, we need to activate we need to apply the activation function to keep the flux of information. And that's why we specify the activation function. Now, as I mentioned, from the machine learning paradigm, to train a model will be like an optimization process, in the sense that we make a random guess, we compare the random guess with the true value. With this, we can compute an error, we can estimate an error, and we can use this error to variate the values of the weights of my network in order to improve our guesses. So the idea is that, since it's an optimization process, to optimize means like to compute maximums or minimums, and to compute maximums or minimums means that I have to derivate at some point. And that's why we actually use an activation function, because we work, what TensorFlow does actually is that at a very low level, it works with gradients. It differentiates the activation function, computes the error, and at the very low level, does all the optimization process. That may seem to be something difficult, and maybe on the implementation part, it might be, if maybe you're not quite familiar on these kind of topics. But the idea is that TensorFlow, in a very high level, will do everything in a very easy way. As we can see, we can create a model with only 4 lines. I have defined an input layer, an output layer, and a hidden layer. So after all this talk, all this chattering, explaining what will be happening, I can run my model. I can specify more parameters about my model, because I need to compile the model. And what I need to compile the model is that I need to specify the way that I am going to be measuring the error that is given by my guess. If we think again of my machine learning paradigm, it will happen that I compute an error, and the way of computing an error may depend on a mathematical function that I use to measure the similarity of my guess with the true values of my sample data. So this is what we used for this loss function. And we also need an optimizer, because the optimizer will help us like to minimize that error, since we continue guessing and trying to approach my guesses to the true values of my samples. We need to be varying the values of my weights in my neural network. So what we use, or what will happen in a very low level, is that with the activation function, we compute the derivative, and using the optimizer, it will be jumping to the place or to the direction where the minimum of my general function that describes my data, it's going to be. So this might be a bit abstract at some point, but in a very high level, our optimizer is the way that we are going to be approximating to the minimum error possible to improve our guesses. And that's it. That's the thing that we are that we need to understand. Finally, just the metrics. We can focus on the accuracy or maybe on the loss if we want to minimize the error. But that's it. I can compile my model, and I can train my model just calling the fit method. This method needs to we need to specify some parameters to this method. First of all, we need to specify the example, the data set that is going to be used for training. So I directly pass the training images list and the training labels list. As we saw previously, we have the images, and each image has a associated label. So for instance, label 3 corresponds to dresses, label 0 corresponds to tennis, and so on. So we will be using like the raw images and the label that we want to predict. So this is going to be used for our random guess and just to minimize the error of prediction of the class. And as I mentioned on my machine learning paradigm, when we are working with our guesses and we are working on improving the guess, this is an iterative process because we need to repeat this process several times until we reach a reasonable low error or a reasonable high accuracy. So this means that our model actually performs with good predictions. And for this, we specify the number of epochs, or we can think of these epochs like the number of iterations that we are going to repeat the process of trying to guess, estimate an error, modify the weights of my network to improve the accuracy, and how many times it is going to be repeated. So I can directly run this block of code, and I can see that I am going to be training my model for 5 epochs. TensorFlow is going to show me the time that it takes to train per epoch my model. It will be also showing the value of my error for the guesses based on the function to compute this similarity to measure this error. And finally, it will be measuring the accuracy for the training images. For instance, we can think of this that if we had a set of 100 images, we can think that at this point, after 5 epochs, our models guesses correctly 89 images out of the 100 images. So the idea is that this could be relative. This could be relative because this may not actually give us accurate information about the performance of the model. Why? Because if we think about this example of the kid and his mom, when her mom told him, like, look, son, this is a dog, and the kid learned how a dog looks like, maybe it could happen that her mother only showed him Chihuahua dogs. And Chihuahua dogs are like very, very small dogs with very big eyes and yes, for some people, ugly dogs. For other people, some people love those dogs. But in this case, thinking about this example, if the mother showed the kid only Chihuahua dogs, if the kid sees at some point a Labrador dog, or maybe a dog from a breed that tend to have a big size, maybe the kid won't know what that animal is, and maybe this kid won't be able to identify that it's a dog because all the dogs that the kid has seen are only Chihuahua dogs. The idea is that because of thinking of on this example, maybe the model has just seen very specific data, and it has fallen in a case of overfitting. When we look to very, very specific data, not in data that could generalize my data set, we say that our model overfitted. And for instance, in the case of the kid, if the kid only saw Chihuahuas, the kid has a bias, right? Because he only knows to identify Chihuahuas, but not every kind of dogs. So during the training of the kid has overfitted um, on how he predicts what a dog is. So this is why this accuracy may not be like very accurate at all, because this accuracy is measured over the training images. And this is why we make use of the test images. And we can call the method evaluate of the model object, which will compute actually the loss and the accuracy measured but over the the test images. So the model evaluates its performance with images that it has not seen yet. And this is the idea of splitting the data set in training and testing subsets. And that's it. We can think about an accuracy of 86%, 86.72% of accuracy for our model. So it's reasonably good. So now that we have trained the model, we can make predictions. How do we make predictions with the model? But maybe our intuition tell us how to do it, because if we see, once we create an instance of a sequential model, the model has a method that compiles, the model has a method that fits or trains the network. The method has the model has a method that evaluates the model. Finally, the model will have a method exactly to predict information. And we will just need to specify the data that we are going to be to use to feed the network. So the network will make an inference and will classify the data that we're going to use. So in this block of code, I've done this. Let me just split this specific part of code just to explain what is happening. Input image, it's going to be this. You can leave the code as it was. It will work perfectly without any problem. But I just want to split to explain what will happen. What I will do is that I will plot a test image with the index that I will specify. I can think of index 300 or whatever index between 0 and between the 10,000 number of indices we have. So I will be using the test index 300. So it will display the test image with index 300 from the test images. And I will print out the label, the original label, because I am loading the label directly from the test labels list. Now, what I want to do is that I will take this image from this index and I will feed my neural network with that image, so my network can inference and give us a prediction about this image that I am going to use to test. Now, I will just cut this code, and because first of all, I want to see what my image is. Oh, okay, it's address, so it corresponds to label 3, to class 3. So what I will do is that, let me just split this one too. What I will do is that, first of all, my TensorFlow model, it's fed with an image that is 28 by 28 pixels. But when we create a TensorFlow model, specifically when we work with more than one-dimensional arrays, what will happen is that it will need to create an extra channel that will be used to iterate over all the images. So what I am doing here is that if I take an image from the test images list, I will just add a number 1 to the axis, but it will preserve actually the representation of the matrix. I'm not doing any operation. I'm just adding one dimension, which means that I'm just adding a set of brackets for the whole matrix, and that's it. And this input image, it's going to be passed to the model, so the model can make a prediction. And now that I have a prediction, let's see how the prediction looks like. Prediction. If I print the prediction, I will see that this is an array of dimension 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the output of the network, once that it has given us a prediction of our input image that is addressed, it will give us like a number of probabilities that our input image is associated to the corresponding class. So what we need to do is just to find the value that gives us the maximum value, which we can interpret the highest probability of corresponding to this class. So actually, as we can see, we are in the order of 2.55 times 10 elevated to the power of -4. This one is actually 0.9956. So we can see that this is actually the maximum argument of the vector. So the prediction would be the positional index of that class. So 0, 1, 2, 3. The prediction is that this image corresponds to the class number 3. And if I compute the maximum argument of this vector, we will get the index that I've just mentioned, which is our prediction is that this image corresponds to class number 3, and the original label is number 3. So our network actually performed well over this input image. You can continue exploring this part once that you have trained the model. You can try with another image, maybe the image from the testing set with index number 3, which corresponds to label 8 courses. And we can directly run the cells and see that the prediction corresponds actually to the class. So we can see that for many cases, our model will perform well. Okay, what would be our next steps, or what could we be working on? We can think about improving our model, and in this case, we could add more hidden layers. So we could have more neurons that could map better relations in the data. So let's try with another hidden layer. So I will just copy one dense layer and add another layer. And let me just see how many neurons can we add to this. Since first of all, we flatten in the input layer, right? So we have the input layer would be a vector of 784. So let's try a number of neurons between 128 and 784. Let's try maybe 256. Okay, let's try. Yeah, let's try with that number of neurons. We can create a new model with new configuration on its architecture. We can compile this new model. We can train the model, and we could see if it performs better on the during the training. So let's see. Okay, after epoch 3, the accuracy value also almost reaches our previous accuracy value. So actually, it seems that it performs better. Let's evaluate the model over the test images and see if this our neural network configuration performs better than our first one. It seems to perform a bit better, so I would expect good prediction. So far, I will try to be closing up. So far, we have explored how we can build models, a very basic model, our very first neural network using TensorFlow, using the high-level API inside TensorFlow, that is Keras. And as we can see, in a very simple way, with only a few lines of code, we can create a neural network. And actually, we could try to go deeper and add more layers, which actually may not perform better than this architecture that we already have. But this is something that you can experiment with, and this is why I'm sharing the code with you. So you can explore the following situations. You can modify the number of layers and neurons per layer. So you can actually see what happens if you keep adding more layers or you change the number of neurons on the layers that you have. Another thing that you can try is to modify the number of training epochs. Actually, let's think about this. If we go back to our kid example, maybe in an iteration of 5 epochs, the kid only saw a small number of dogs. So maybe if we continue showing him dogs, the kid would know better the features of the dogs, and the kid will know better how to identify a dog. So an idea could be to add more epochs to the training process and see if the model keeps improving. So actually, we can see that since I continue training the last model, we are getting better results with more epochs. Another thing, meanwhile, while this is training, another thing that you could try is to explore the performance of specific architectures, like the ones that you will be exploring, but with different data sets. At the beginning, I shared with you that Keras already has different data sets that you can import and directly use. Maybe it would be interesting to compare the performance of the architecture of one neural network when you use the fashion MNIST dataset, that is the one that we are currently using, compared with the MNIST dataset, which is the dataset to identify or to classify handwritten digits. So okay, now we have trained the model for more epochs, and we see that it improved the accuracy a bit. Now, next steps for this, and these are actually steps that you will be working on for the next sessions of these workshops. What could be next steps? First of all, since I am working with a data set that is composed by images, there are specific architectures of neural networks, or at least specific layers that help a lot when you work with computer vision problems. And that's what we are going to be working on for the next session. And besides this, a next step could be to explore more also about these layers that are here documented in the TensorFlow webpage. So you can explore other kind of layers that you can find, not only the layers that I have shared with you. You can like explore more the TensorFlow package. And what else? I was going to mention something, but I think that I lost it. And yes, next steps would be that once that I have trained the model, it would be interesting for me to export this training model from my Google Colab notebook to another place in which I can use or apply my trained model to solve a real world problem. So TensorFlow is very useful for this also. So in the next sessions, actually, you will learn how to use TensorFlow JS, like to create your own app, and how to use TensorFlow Lite if you want to create your mobile application that uses TensorFlow, for instance. And the idea is that you can export these models, so you can port them to real world applications. And this is also a set of next steps that you will be exploring through the next workshop. So far, we have seen how a neural network works, how it can be implemented in TensorFlow, and I tried to explain. I tried to do my best explaining how the training is performed, how we can make predictions with the network, and what is happening in the background when we create a model and when we train the model with this machine learning paradigm. Uh, Obviously, this is at a high level, because if I take a lot of time explaining like all the mathematics behind, it will take maybe a lot of time, and I would just get people confused, and I don't want that. I actually want the opposite. I want people to see that actually building a neural network with TensorFlow, it's very easy. I can build a model with 5 lines of code. So that's like the goal of this workshop. And I don't know if there are some questions so far. So I'm back to you, Rolf.
I think we do have some questions coming from the comments. I think the first question is, I'll just go to show it. So, is it recommended to always use Adam as an optimizer? Is there any situation where we should use something else? Example, SGD.
Uh, it depends. I think that it depends on the problem you're working on, because what the SGD does is that the way it optimizes, it's like considering like a stochastic factor, in the way that when it's in the iteration process, it's jumping to reach like a minimum. With this stochastic factor, it tries to avoid falling into local minimas. So it tries to reach to a global minima. So it may be depend. It may depend on the problem that you're working on. Adam actually performs very good, so you can in your first try work with Adam and see how the training performs. Maybe if you try with SGD and actually specify the learning rate, you could reach better results.
Okay. Another question from Nico Aguila. How do you determine the optimal number of layers to generate for your model? Is it like a trial and error process, or do you have a specific criteria that you have based on your experience?
That's a very good question, and actually, that's there's a lot of people that work researching on the architecture of the networks, on which configurations give better results. Well, it actually depends. If you have a sequential model, more layers will not always result into good results. Will not, sorry for that redundancy, will not give you good results. And there's not, at least for me, a direct way like to have or to specify an optimal number of layers. You can think actually in the size of your input image. Maybe if I had a larger input vector, for instance, in our example, we were using a 784 sized vector. Maybe if we have 4 times that vector, I would try with two with 2 or 3 hidden layers. Why? Because what happens with neural networks is that at a very high level, as I mentioned before, the neural network learns complex relations of the data. And what happens is that I'm not sure if sorry, I thought that yeah, okay, you're showing the screen. And what happens is that at a high level, the neural network learns a better representation of the features that are important from your data. So that's what I would do. If I see that I have a very long vector, I would try to add layers that try to rescue some important features during the process of stacking layers, right?
Okay. Another question. I think this is referring to the workshop that, or the code that you were able to show a while ago. Does the model that you were able to show have the hidden layers, or is it only two layers? I think on a general question, how do you differentiate this model that you are actually, or the model that you are able to show a while ago?
I think that I lost you a bit, Ralph. Okay, it's loading. Oh, sorry, I think that I lost you for a
Yeah,
moment.
sorry. Yeah. I think the question is like, does the model that you were able to share a while ago have three hidden layers or just only two hidden layers? And how do you like decide? How do you define what's a hidden layer? And yeah, sometimes people are confused about like the input layer and then the hidden layer and then the output layer. So how do you make it clear in terms of like explaining all of those key concepts?
Okay. Can you share my my screen, please?
So three.
Okay. So, okay, I have my code here. Um, Here I have my sequential model. I can identify the layers because the last one, it's always going to be the output layer. And the first one, it's going to be always the input layer. So actually my input layer will not always be a flattened layer. Maybe I could have, actually we will see that in the next session. I could have another kind of layer depending on the architecture of my network. But yes, the easiest way to identify is the first one is always going to be the input, and the last one is always going to be the output layer. And the layers that are in between are the hidden layers. So in this case, this is here I have two hidden layers.
Okay, another question is like, they just would want to like, can you explain again why we use dense 128 for one of the hidden layers?
Okay, yes. So the idea is that I will create a cell here. I have a lot of data. One 783, 784. I have an array containing the pixel values in a vector. And the idea is that neural networks learn the important features during the training. The neural networks learn the important features or the important parts of the data during the training. So the idea is that as we keep adding layers, the layers have less units than the input layer, right? So the idea is that these 260 and 56 neurons will encode in some way, will encode the important features of the input data in a vector that has a lower size. And that's what will happen. Actually, 128 sounds like a reasonable number of values to have a representation of the important features of the input vector. So the idea is that actually we are as we have layers, the units, the neurons, will be rescuing some information. And the idea is that we will only need like smaller size of vectors with the representation of the important features. And this is something that happens with neural networks. Neural networks learn like in like the important features during the training. And yes, that's actually the magic of the neural networks. I think that for the next session, I can think of more example for this, because since we are going to be working with images, we will be it will be clear. Yes, it will be more clear for us to understand what will happen at a high level, and how the neural network encodes the whole information in smaller smaller units.
Okay. Another question, Rodolfo. I think you were able like to show this a while ago when you run the training set. So I think in terms of the current model that you were able to build, how long this model was trained, and I think in terms of like, the actual setup of Colab, what are you using so that in terms of consideration of like what machines to use, I think there's an impact on that as well. Maybe you can like give a overview, like how long was this model trained, and what are the specifics of like what machine are you using?
Okay. Okay, yeah, some specifications about my machine. This environment, Google Colab, actually has, I am using a GPU. That's why my training actually did not take too long. Actually, as I can see, per epoch, it just took 3 seconds. So this model was not trained for too long. This model was actually trained for 15 epochs, because I first trained over 5 epochs, and then with the same model I trained it another 10 epochs. So yes, usually it depends also on the problem. I have worked with some other problems. Let me think about an example. Okay, I worked for a big challenge, a global challenge, where we try to identify trees on satellite images. So it was a segmentation problem, because we wanted to create like a mask that could be overlaid over images of over satellite images to identify trees. What happened with this is that we had larger data sets, and actually our model was way too complex. So actually we had another kind of layers. We were not using dense layer. Actually, we were using convolutional layers. We are going to be talking about that on the next session. And the model was not a sequential model. It had a very specific configuration. Actually, we replicated a UNet model for that particular case. And it happened that during the training took more time, and it depends on the configuration of your network, the number of data that you are using to train the network, and so on. So there are some parameters that will allow you to estimate, or at least have an idea if a model is going to take longer or less to train.
Okay, I think that's all the questions that we have. The questions from my side, especially for beginners who are joining us today, what is a good advice for them to start their way into exploring machine learning and TensorFlow, and what resources that you would want to recommend for them to like go over and read.
Okay, let me think about the first question. How could I motivate people? Well, actually, I think that deep learning and artificial intelligence, it's gaining more presence nowadays in the whole world. So actually, I think that it's important to think on moving to these technologies, because of the presence, and at least to have an idea of how these things work. But an interesting thing is that you already know how to program, this could be an excellent opportunity to keep expanding your knowledge on new technologies. And the cool thing about TensorFlow is that you could do like very complex processes in a very simple way, as we have seen. If we think about creating artificial intelligence many years ago, I think that that would be a chaos. I couldn't imagine all the code that researchers had to write at that time, right? But right now it's quite simple, and you can take an advantage of that. You can also think about making some applications that are relevant for you. Maybe if you are a person that plays video games, you can think on how to build bots that are intelligent and play by themselves some video games. You can find a lot of videos about that on YouTube, actually. And some of resources to keep learning about TensorFlow and so on. If you want to first of all, if you want to get deeper in understanding how neural networks work, you can check out, there's an online book called Neural Networks and DeepLearning.com. That's a good reference because they built from scratch a neural network that actually solves the MNIST problem. If you want to explore more about TensorFlow examples and applications, I recommend you to follow the TensorFlow blog, actually, because they have a lot of posts that some of them are from people that work at Google, some of them are from people that are part of the GDE program, and they actually explain in a very nice way and have code that it's already on Google Colab, so you can directly open the notebook and explore what's happening. Actually, the TensorFlow documentation has a lot of examples that are very interesting. If you want to explore more deeper models, you can think about generative models, and you will find all the code already implemented in the TensorFlow documentation. So you should take a look at the TensorFlow examples from the TensorFlow page, and you will find a lot of very useful examples, and you will understand more how can you use TensorFlow for more, let's say, deep applications.
Okay, thank you so much, Rodolfo. I think it's an early day for you to start since you're based in Mexico. Thank you so much for your time and spending and sharing your knowledge with us today. And we're hope to see you again next week as you relatively share image classification on TensorFlow. So thank you so much, Rodolfo, and thanks also for all of the people who joined us here today. And hope you guys learned. Thank you guys, everyone. Thanks, Rodolfo.
Thank you. Bye bye.